You'll see in every newspaper, every journal, every article that you look at, somebody is using machine learning for something new out there. Either they're claiming it's a good thing or it's a bad thing. But at its basic form, machine learning is just a bunch of mathematical algorithms. It's just a bunch of equations. Some of them have got really fancy names, but most of them have been around for decades, often centuries. So you'll hear terms like neural networks, deep learning, Bayesian inference, logistic regression. They're all really fancy names, but at its heart, all it's trying to do is take a bunch of data that occurred in the past and try to predict what's going to occur in the future. One of the things people fear about when they hear about machine learning is all the bad things that people suspect it's going to be used for. People fear about computers and machine learning taking over their jobs. Now, we've heard lots of these predictions over the years, over the decades. We've heard it with telephone operators, we've heard it with loom operators through the textile revolution. Personally, I don't believe any of this will occur. New jobs will spring up from it. If we believe these predictions, many of the jobs that we've got today just simply wouldn't exist. If we look at a wonderful example in Germany, where we've got some of the highest use of technology and the highest use of robotic automation in manufacturing, it's equally in the region where you've got the highest paid salaries and the lowest amount of unemployment. So there's some terms out there that are often used interchangeably. So things like AI and ML, so artificial intelligence and machine learning. So whilst these two disciplines are very, very related, they are different. So in my simplistic world, the easiest way I can describe it is AI is where you're trying to get a computer to imitate a human. It's trying to be true artificial intelligence. It's trying to act in a way that you can't tell that you're dealing with a machine versus a human. Machine learning is a subset of AI. What it's trying to do is, in a very narrow problem domain, predict an outcome, help you make a decision. So showing a picture of a face, be able to say, who is this person? Hearing a voice, being able to say, who is the person speaking? Are they stressed or not? Seeing a bunch of financial data, be able to predict, is this person a good credit risk or a bad credit risk? All of those are great examples of machine learning. Where you start blurring into the artificial intelligence domain are things like driverless cars, Siri, Alexa. All of them are trying to pretend to be a human being and interact with you at the human level. We embarked on a journey to discover which are the best types of machine learning for the kind of problem domains that we help our clients solve. So things like credit risk, affordability risk, fraud detection in both application of loans, but also insurance claims, insurance policy pricing. And what we wanted to do was to approach this from a no assumptions perspective. We didn't know exactly which machine learning algorithms would be best in each of those different types of problem domains. So what we did was we mapped every machine learning algorithm that we could find against those different problem domains and looked to see which was the most predictive. The results of this were really encouraging because one or two algorithms absolutely floated to the top with the highest level of predictiveness, but also a really strong stability quotient. These models are outperforming all of our traditional models by several Gini points. What that means is that level of higher predictiveness will enable our clients to make sure that they make better loan decisions faster. That's good for the clients, it's good for consumers, and it's good for the economy at home.